Hello team, today's challenge is parentheses combinations, where we're given a number, which is the number of parentheses, the number of parentheses pairs, sorry, and we need to figure out how many combinations we can make out of those. So in the case of two, there are only two valid combinations where we put one set inside of the other set or put the two sets side by side, right? We aren't allowed to start with a closing parentheses. We aren't allowed to mix and match them in just random ways, right? We always have to open as a start, and then we can keep opening or close and open again, right? And that's kind of what we're going for here. All this relies on another version of a binomial coefficient. This is not the first time that we've talked about those. In fact, we have talked about those over here in Pascal's triangle, right? Where we were asked to get the, in this case, an array, but that array matched up with whatever the row was. So we got an n there, we got the row, and we returned the numbers from that row. And if you remember that, I'm not going to explain all this code, but our code is going to be very similar, right? We're going to have some sort of an output. It's not going to be an array, but we're going to capture that output. We're going to loop through here and do some stuff. And we're going to do something very similar to this. In that video, I explained that this right here, this bit with the division, is the magic behind this specific challenge, right? So what ends up happening is the top number starts out really big, right? As big as it can, n minus 1, whatever that is. And then the bottom number starts out really small. In this case, it started out as 1, right? And as it goes, the bottom number gets bigger because it goes through the loop. The top number gets smaller because we're subtracting that I from the number, and they end up flipping at some point, which is how this logic right here goes all the way big, and then on the other side it goes small again. Well, we're going to do the not the exact same thing, but something very similar. Instead, for this, we're going to use something, or we're going to create something called a Catalan number, okay, which looks pretty much the same, right, behind the hood or underneath the hood, but we are going to add a little extra math, right? Just a little. Again, it's going to look very similar. You can compare them afterwards and go, oh yeah, I see it. But for now, we can just get into it, okay? So if we had that if statement, just like the other one, so if less than equal to 0, then we should return, well, 0. There are no combinations, so we return 0, okay? Down here, we set up our output. So output equals 1, okay? We're going to start at 1, and for, this is going to be our for loop, let I equal, we're going to start at 0 this time. I is less than n, and I plus plus, okay? Just like that. And then down here, we do the exact same thing. We output just like that, okay? And just to help us along, I did copy and paste this so that we can see that that bit of magic happen, okay? Now again, with our original challenge, we got the previous value and multiplied it by this fraction, right? So the previous value multiplied by this fraction. Well, here we only have the one value because it's a number. So we can actually simplify that a little bit and just go output times equals, just like this, our fraction, right? Which will be very, very similar. In this case, it will be, instead of n minus 1, right? N minus 1, we're going to do, or sorry, n minus I. I keep seeing a 1 here for some reason. But instead of n minus I, we're going to go 2 times n minus I. And that 2 is kind of what makes all of this work, okay? And then, of course, we divide by this one, which is I plus 1, okay? And we need to do that I plus 1 because we're starting at 0 here. If, by chance, we did not do plus 1, then we would be trying to divide by 0, which is always an error, right? You can't divide by 0. It's not possible. So we need to plus 1, which is why we do this, and that will give us an output. but it will not give us this output. Instead, what we get is a really big number, and we need to divide that number by n plus 1. And that's what this final bit is. So divide by n plus 1, just like this, not like that, in parentheses, n plus 1, and it works, okay? So hopefully you can see this, where this was from Pascal's triangle, right? A bit of a simpler version, and this kind of doing the same, except that this time we are multiplying by 2, okay? Now, in order to see what that looks like, here's a little bit of a comment. Excellent, okay? So if we started out at 3, right? N is 3, I is 0. That is 2 times 3 is 6, minus 0 is 6, which is what we have here. And then, of course, 0 plus 1, that's the 1. And we keep going through that loop, so we get 5 and 2, 4 and 3, and we stop because we're only allowed to have 3 items, right? That's kind of what we're doing here. So good, we're there. Now, we multiply them together, okay? So 6 divided by 1 times 5 divided by 2 times 4 divided by 3, that all equals 20, right? It ends up being 20. And then we take that 20 and divide it by 3 plus 1, which is 4, right? That's what we've done here. So 20 divided by 4 equals 5, and that is our answer. And again, this 5, this output here, is what's referred to as a Catalan number. So Eugene Catalan, this gentleman here, if I hover it, right, a French-Belgian mathematician, worked through it and figured out how this combination system works. Okay, and so they named it after him. It was also discovered by a Mongolian scientist, Mingatu. I hope I said that right. But they named it after Catalan for reasons that are beyond me. Okay. With that though, they both figured this out, and they figured out that you can do things like, if you had a polygon, right? In this case, it's a 5-pointed polygon. You can figure out how many different ways you can slice into that polygon without crossing over things. So unique partitions, there are 40 through the middle, and then the whole thing here and none of it here equals 42, right? And that is the fifth number. So this is 0, 1, 2, 3, 4, 5. The fifth one is 42, which is how many partitions are in this image, right? Going further, as we go down, they will have some binary trees, right? So very interesting stuff. In fact, they translate this back to parentheses, which is kind of interesting. So we get a little bit of interesting parentheses stuff going on here. Some different binary trees, slicing and dicing, going through the thing. And then we come to mountain ranges. Okay, and this is what I wanted to finish on before going back and reviewing. But we have forward and backward slash, and the idea is to create these unique mountain ranges. You can never go down before you can go up, because you're not allowed to go below sea level for that challenge. Well, what if we change these to parentheses, opening and closing? Well, now it's the exact same challenge, right? So bonus to us, if they give us a mountain ranges challenge sometime in the future, we've already solved it. We just need to copy and paste our code over, and it works, right? And we can get on with things. So very interesting times, very huge, very complex read. And I don't claim to understand the math completely, but I love that it works. So back over here, we started out by setting up our output, right? We checked to make sure that we had something greater than 0. Otherwise, what's the point, right? If we don't have 0, if we don't have a number greater than 0, then we don't have anything that we can do combinations on. It's that simple, okay? And then from there, we set up our output, starting at 1, because it does. This is kind of all these binomial coefficients. They're kind of like Fibonacci sequence, which maybe the Fibonacci sequence is a binomial coefficient. I never thought to look that up, but right here, right, it starts at 1, and then the next number is 1 and then 2 and then 5, right? Instead of the Fibonacci sequence, which is 1, 1, 2, 3, 5, so on, etc., right? So they all kind of start at 1 like this, which is how we started today. And then we set up our loop. So 0 less than n plus plus, pretty standard stuff. And then we figured out that fraction. Just like Pascal's triangle, Pascal's triangle uses this fraction for what we're doing. We're trying to generate Catalan numbers, and that uses this fraction, okay? We multiply all that together and then do a little bit of division at the end to get our final output, okay? So very long description for something that could have taken like a minute and a half to type out, but this is where we are, okay? Let me know in the comments. Did you like it? Did you hate it? Did you go a different way, right? We could do some recursion. I think there's a way to do a recursive function for this, but the loop works pretty good. So I'm going to stick with that. If you did try that way and you want to share it, hit me up in those comments. Otherwise, today this has been parentheses combinations, and I will see you in the next one.